Hello. Today we're going to go through two learning targets, the 2.0 and the 3.0. And these are 5.2.1b and 5.3.1. And these are both talking about the perimeter and area ratios. And so as we're going through these notes, if you need to pause to make sure that you are caught up, you can do so and then just continue watching. So the first thing that we want to talk about is we've already talked about the similarity ratio. So when you have similar polygons, we've discussed how you write your similarity ratio. So the ratio of all of the sides when they end up being equal. And now we're going to add on the perimeter and area ratios to that understanding. So at the very top, we're just going to define each one. So I'm just going to kind of draw a little box with 3 columns in it. And we have our similarity ratio. And just leave like a little space. We have our perimeter ratio. And we have our area ratio. And so let's say we have 2 triangles that we know are similar. So let's use like this example. So we have this triangle and we have this triangle. And we know that these are similar, and this has side A and this has side B. These are similar. And so in this case, our similarity ratio would be the ratio of one side to the other. And you can choose which is on top, like which is the top shape and which is the bottom. It doesn't really matter, but it's just going to be one side over the other. So A over B. And the perimeter ratio is actually the exact same thing. So when we find perimeter, remember we're just adding up all the sides. So the ratio of this perimeter to this perimeter is going to be exactly the same. It's still A over B. So if shape A is twice as big as shape B, then the perimeter of shape A will be twice as big as shape B. That's what that's saying. The area ratio is a little bit different. This is A squared over B squared. And hopefully you remember that because when we find the area, we are finding units squared anyway, so you have to remember to square these. And so what that's saying is that the area of shape A is not twice as big as B, it's now 2 squared as big as B. And so these are the ratios you're going to need to know. And in the 2.0 level, we are just finding those ratios. So if I give you a similar set of shapes, can you just tell me what is the similarity ratio, what's the perimeter, and what's the area? And so let's do an example of one of those. So let's say that we have rectangles this time. So we have A, B, C, D is similar to rectangle W, X, Y, Z. And we have a picture here of rectangle A, B, C, D. And we know this side is 18 and this one's 36. And then we have a bigger rectangle W, X, Y, Z. And we know just the top side is 25. And so now the 2.0 level is to be able to identify all 3 ratios. So the similarity ratio, the perimeter ratio, and the area ratio. And so the first thing that you want to do is you want to find corresponding sides, and you only need one set because it's already telling us that they're similar, so all sets of corresponding sides will be the same ratio. And so in this case, I know that I have AB, and then I just want to make sure I'm using the same corresponding side, which is WX. So in that case, we again want to choose a top shape and a bottom shape, just like we've been doing. And you want to be consistent with all three ratios. So your similarity ratio is going to be 18 over 25. And just leave it as a fraction. You don't even need to reduce it, just leave it as whatever it is so you can very clearly see where those numbers came from. The perimeter ratio is the exact same, so 18 over 25. The area ratio is the only one that's different, and you just need to square them. So 18 squared over 25 squared. And again, I don't even need you to figure out what this is. Like, I don't need you to do 18 squared and 25 squared. Just leave it as this because you can clearly see where the sides came from. And so that's the 2.0 level, just identifying the ratios. The 3.0 level is where we get into solving for missing values. So just like we've been doing, but now we're going to use these perimeter and area ratios to solve for maybe a missing perimeter or a missing area. So let's do one example of those as well. So for these 3.0 level ones, sometimes they're written in like a story problem and you need to write the picture, and then sometimes they're giving you a picture. I do want to show you just one of the story problems ones because you're going to need to do that in your practice. So let's say we have something like this. You don't need to write this story down, but it says you decide to make a geometrically similar triangular gardens. Your first smaller triangular garden, that is very hard to say in a row, has one side length equal to 3 feet. Your second triangular garden, I did it, has a side length of 9. Perimeter of 36 feet, and an area of 54 feet squared. Find the perimeter and area of the smaller garden. So whenever they give you this like information in words, you want to draw your own picture because it's going to be super helpful. So the first thing I know is that they're both triangles, one smaller than the other. So I have a smaller triangle, I have a bigger triangle. And mine are kind of small because I don't have unlimited space, but if you're just doing it on a notebook, you can draw them as big as you want. And it says the smaller one has a side length equal to 3 feet. So the thing I know is that one of the sides is equal to 3. And then I want to do the other one. It has a side length of 9, and I want to do the matching side. So I'm going to do the 9 here. It has a perimeter of 36. And so how I note those is I just do like inside the triangle, this perimeter is 36, and an area of 54 feet squared. And then it says I want to find the missing perimeter and area of this smaller garden. So I'm trying to find this perimeter and this area. And instead of like, normally when you find perimeter and area, you have all the sides, but I don't have enough information to find that here. So we're going to use our perimeter and area ratios to find that. So the perimeter ratio, I kind of like to split my work up right in half. So I have all my work for perimeter here and all my work for area over here. And the perimeter ratio is exactly the same as the similarity. So it's just a side over the side. So 3 over 9. And so start with the correct ratio. So this is my perimeter ratio. And then we're going to set that equal to, and we're going to do our missing values. So you see I started with the 3, and the perimeter of that triangle is the missing one. So that's my P that I'm looking for. And I know the perimeter over here is 36. So now we are going to just cross multiply like we've been doing in our previous problems. So we have 3 times 36 If I can find my calculator. Is 108, and p times 9 gives me 9p. And then I can just divide 108 divided by 9, which gives me 12. So my perimeter of my smaller one is 12. And they told me that this unit was in feet, so I'm going to put my units as well. So the perimeter is 12 feet. And now you're going to do the same thing for the area, but you're going to use the area ratio. So let me just move this up a little bit. And so now the area ratio is not 3/9. Remember, the area ratio is squared. So we're going to start with the area ratio, which is 3 squared over 9 squared. Okay, see the difference? So for perimeter, you use this one. For area, you use this one. Make sure you're using the right one. And then again, my smaller triangle, the one with 3, which is my top shape, the area is missing. And the bottom one is 54. Do not square this. Don't square this. This is already squared. It is already the area. So do not square this. You only square your actual ratio. Do not square the area that they give you. So before I can cross multiply, I do need to simplify this. Okay, so I do need to see what this equals. So 3 squared is 9, and 9 squared is 81. So you do have an extra step with your area one where you do have to square these. But then we're just going to cross multiply. So 9 times 54 gives me 486. And 81 times A gives me 81A. And then I can just divide both sides by 81 to give me 6. So my area is 6 feet squared. Remember to use the unit. So for these 3.01s, it's really important that if they don't give you a picture, you draw your own. And then make sure you use the correct ratio for each thing you're trying to find. So when you're trying to use perimeter, you just do a side over the side. But when you're trying to use area, that's when you do the side squared over the side squared. So I know this was a little bit of a longer video, but it did cover both the 2.0 and the 3.0. And so I hope that you have a solid understanding of perimeter and area ratios. And I hope you have a great day.